Gonna see an amazing problem. So this is being asked like in almost most of the interviews. So this is the most interesting problem, easiest, and yeah, let's jump straight to the problem. So the problem name is bottom view of binary tree. So I hope everyone knows like what is a binary tree, right? A binary tree means there is a node, it can have at most one or two children, it can have more than that, it cannot have that. So the problem, that's it, and our challenge is we need to find the bottom view of the binary tree. So what does bottom view mean? So let me just quickly show you. We have this, and let's say something like nodes here. So if a person is standing here and if he is looking, so you need to print all the nodes that is visible in his eyes. So generally we will say whatever he is seeing, he will be able to see only the last row, right? No, that's completely wrong. He will be able to see this node, this node, this node, this node, and also through this gap, right, he will be also be able to see this node and also this node. But unfortunately he won't be able to see this node, since this and this one will be blocking this vision. So only these nodes will be visible. So to be more clear, if we do something like 1 2, oh my god, I'm so bad at drawing though, here, 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 now again let's do here, 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 and let's say here, 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 and here. So if a person is watching this, it will be like he will be able to watch this, this one, this, 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 this gap, this. So here you saw, right, instead of one, this part is also not visible now. Earlier this part was visible. So that is the problem, like we are trying to figure out. So how do we solve this problem? So before that, let's try to trace out. So what is the bottom view of this? He'll be able to see 5, he'll be able to see 10. 10 is blocked by 8, then 3 there is a gap, 14 there is a gap, and straight to 320 not possible, 22, 14 is blocking, right? So only 25. So 5, 10, 3, 14, 25. If we draw straight lines, no, that should not block. So 5, then 10, then 3 and 4 together, then 14, then 25. Okay, I'll update later. Yeah, so that is the thing, 3 1 2. So next thing is, how do we gonna solve this? So there is a standard solution that exists, so we can discuss that. So first what we do is let's take a new section. Okay, all right, so we can take the same numbers, that is 10 20 30 40 60. So this is 10, how much is this, 20 30 40 and 60. Now if we, what did I say, like we have to get the straight lines, right? So 40 will be visible, 20 will be visible, 60 will be visible, 10 is blocked, right? 30 will be visible. How do we get it? So for this we need to construct a queue. I hope most of you might know what is a queue data structure, right? Whatever comes first through this, it will be comes out. So suppose I push 1 will come out. If I push 2 will come out next after 1, 3 will come out, like that. So let me quickly erase this. Okay, now let's jump straight to the problem. So what we do, we used to construct a queue data structure. So first thing, what are they giving? They will be giving the root, right? So we will insert 10. Now 10 is having two things. So what is this? 10 is having 20 and 30, right? So we can construct this queue directly, but we need to actually know the bottom view. So for that we use this algorithm. We know 10, right? We will assume it to be value 0, 0, 20 is there. So just follow this rule, that is, if it is left, you have to do number minus 1. If it is right, you have to do number plus 1. Okay, I'll tell you like why do we do this. 0, 0 minus 1, minus 1. If left is done, we'll check whether the right child is there. Right child is there, correct. And if it is right, what we should do? Number plus 1. So 0 plus 1, this is root number. Okay, so 0 plus 1, how much? That is plus 1. Now 10 has been processed. Now next, this number, right? 20 and minus 1. So 20 have a left child, that is 40, right? Okay, 40. If we go left, what should we do? This is already minus 1. Number minus 1. So minus 1 minus 1, that is minus 2. Okay. Now 20 is also having right child, which is 60. We'll push it. And right child means this root number plus 1. That is what? 0. That's it. Now 20 is also being processed. Now 30 comes. 30 and 30, nobody is there, right? So 30 is also being processed. Now 40, no child is there. 60, nothing is there. But how do we did everything, that is okay. We mapped these numbers to minus 2, 0, everything. Now the answer is very simple. For each line, if you notice properly, there will be only one number if you draw. So for this line, extreme left, there will be one number. For next line, it will be one number. This line, one number, 0, and this line only one number. So for this you can directly do like map. Okay, so MA of 0 you can keep as 10, and map of minus 1 you can keep as what, 20. So like that. Then again MA of plus 1 you can put 30. Then MA of minus 2 you can put 40, and MA of 0, map of 0 is already found. This 10 will be overridden with 60. Okay, so now when you are printing, print in this format in a map. That is, in map always it will be sorted. So minus 1, 0, plus 1, and minus 2 will be here. Minus 2 is how much? 40. Minus 1 how much? It is 20. 0, that is 60, and plus 1 how much? 30. So 40, 20, 60, 30 will be the solution. So we printed from the most least number to the largest number. So I hope it's clear, and I'm pretty sure you guys might know about maps. Maps, in short, maps is just a data structure which will have many keys like X, Y, Z. If you put all keys will be different. If I match Y with 1, and if number 2 comes, suppose if you want to match X and 2 comes. Suppose number 3 want to match with X, 2 gets replaced and X will point to 3. So every key should have a unique value or like multiple values. So there won't be anything like X, X, Y, Z. It's only like X, Y, Z, and everything should be unique. Now let's try to code this. Okay, so for coding we need to understand like what are all the data structures that we need. So earlier I told you, right, here we need a queue. For queue we need to store the node value as well as the integer, that 0, minus 1 and all, right? So we'll declare that. We'll declare the queue, and we can do something like pair which will hold the node and the integer. Okay, perfect. So now the queue's data structure is correct. So we already have this value, that is 10, right? We need to store this one. So we do something like queue dot push of root comma 0. Okay, now what we have to do, we have to create a map. So that is map in comma int ma, and then this 0 should be mapped to root, right? That is ma of 0 equals root the value. So we called it generally data. Now we have to iterate the queue until it is empty. We are not empty now, so we do while queue not queue dot empty. So I'll be live coding this, so bear with me. Then for each queue element we need a element to operate on, right? So that element is this. So let's call it like front maybe, and this is like queue dot front. Now since here let's example 10 is the front element. Now we stored it in value p front, right? Now we don't need to store it in the queue. We can immediately, what happened? We can immediately pop. Okay, yeah. So now as I told you, we have to check that if 10 is there, does it have a left value? So how will we check? That is, if front is the this queue element, okay, queue elements first value is the node front dot first, and this node's left value is existing or not. So if it is not existing, it will be null, so the condition will be false. So first we got this. Now let's see q dot push. If it is there, we have to push the element, that is the node we will be pushing. Then what did I tell you earlier? If it is left, we have to put the number -1, correct? So what we do is front dot second. This is the front and this is the second, -1. So do I make sense? That's all. And one more thing we did earlier, right? Each of these numbers should be stored in a map. The latest value should be stored, and front -1 should be front dot first. So front dot first is the node. That node's data we need to store, right? Perfect. Now same thing, let's copy paste and modify for right. So first we did like for first, here let's do for right. Okay, now left is there, instead of left we put right. And what did I tell you? Like if left is number -1, right should be number +1, correct? And this is second +1. And front dot second, again here it's +1, and it's not left here, it is also right here. Now all the map has been sorted, -1 +1 -2 +2, many things are there. Now the thing is we have to return this as a vector in the ordered format, correct? So when we do, right, we will, let's say int as result, we will return the result first. So what should the result contain? It should be like for auto, I will take the maps value in a sorted fashion, and then let's do something like let's just push the elements. So I is the element, i's first value in the map is the mapped number -1 +1, like that. Second value is the data. So what we do, I is the second value. Now we have passed the result. So let's just compile and see. Everything is live coding, so perfect. 132 312. So that's all. And always try to practice fully, and we have submitted correctly, so 0.19, so that's pretty decent. And yeah, thank you so much for listening. And if you before that, I can also tell you the time complexity. We will be traversing all the nodes only once, and in the queue data structure we'll be storing the nodes, right? So that is like n nodes, it occurs n space. And this one, the storage space for tree node is like n nodes are there. We need to store this tree somewhere. It can be array format or anything. It needs n space. And time complexity n, since we are traversing n nodes only one time. So hope this video is useful. Thank you guys. Please leave your valuable comments and